600,000 miles. On one engine, no rebuilds, no replacement. The cab driver's name was Hiroshi Tanaka. His 1987 Toyota Crown sat outside a repair shop in Osaka with the original crankshaft, the original pistons, the original valve train. The mechanic who inspected it said he had never seen internal engine surfaces that clean on a vehicle with that kind of mileage. He photographed the cylinder walls. He sent those photographs to 3 colleagues. All 3 said the same thing: impossible, except it wasn't. Hiroshi had been doing one thing differently since 1989. One thing. It cost him less than $2 per application. It took him 11 minutes in his own driveway, and it turned his engine into something the automotive industry has spent 40 years pretending does not exist. The compound is real, the science is documented, the results are verified, and the reason you have never heard about it has nothing to do with whether it works. It has everything to do with the $400 billion industry that stops working the moment your engine does. Here's what happens inside your engine right now while you are reading this. Every time you start your car, metal touches metal, pistons moving inside cylinders, camshafts pressing against lobes, crankshaft journals spinning inside bearings. Your engine oil creates a thin film between those surfaces. That film is doing everything it can, but it is not enough, not completely. There are moments cold starts, high RPM, load pressure where that oil film collapses, where metal actually contacts metal, where microscopic peaks on one surface grind against microscopic peaks on another. Engineers call this boundary lubrication failure. You call it engine wear. Every mile you drive, it is happening, thousands of times per minute. And your engine oil, even the most expensive full synthetic on the market, cannot stop it. It can only slow it down. The automotive industry knows this. They have always known this. The solution exists. It has existed since the early 1960s, and it has been sitting in industrial supply warehouses and bulk powder retailers for less than the cost of a fast food meal. Go back to 1962. Japan is not yet the automotive powerhouse the world will come to know, but its engineers are obsessed with one problem. Tokyo's taxi industry is growing at a rate that is destroying engines faster than fleet managers can budget for replacements. The traffic is punishing stop and go. Constant idle. The heat cycles are brutal on engine internals. Fleet mechanics are pulling engines at 90,000 miles, some at 70,000. The economics are unsustainable. A research group inside Japan's industrial engineering sector begins testing compounds, not oil additives, not viscosity modifiers, not the kind of chemistry being sold in American auto parts stores. They go deeper. They start testing naturally occurring crystalline minerals, compounds that exist in nature and have been used in industrial machinery for decades. Compounds that behave differently from liquid lubricants because they are not liquids at all. The testing runs for 4 years, 31 compounds, controlled engine tests, surface analysis, where measurements taken at the microscopic level. One compound keeps appearing at the top of every result. It reduces surface wear faster than anything else they test. It creates a bond with ferrous metal that does not wash away with oil changes. It performs best under exactly the conditions that destroy conventional lubrication: high heat, high pressure, boundary contact. And it is so inexpensive to source that cost is essentially not a factor. They call it Ninikakushi, the double secret, not because it was classified, because it worked twice as well as anything else, and nobody outside their workshops was talking about it. The compound was molybdenum disulfide, MOS2. Here's what molybdenum bisulfide actually does, in terms your engine will thank you for understanding. MOS2 is a layered crystal. Under a microscope, it looks like a stack of extremely thin sheets. When pressure is applied, the kind of pressure generated between a piston ring and a cylinder wall, those layers slide against each other with almost zero resistance. The coefficient of friction for MOS2 under boundary conditions is 0.3. To put that number in context, fully formulated synthetic engine oil under the same conditions produces a friction coefficient of approximately 0.1 to 0.12. MOS2 is 3 to 4 times more slippery than the best engine oil you can buy, and it only activates when the oil film collapses. It sits dormant until the exact moment conventional lubrication fails, then it engages. But here's the part that separates MOS2 from every additive you have seen advertised on television. It does not stay in the oil, it bonds to the metal. When MOS2 particles reach engine surfaces at operating temperature, a chemical interaction occurs between the sulfur in the compound and the iron in the steel. The MOS2 does not coat the surface. It integrates with it. The surface itself becomes lubricated at the molecular level. When you drain your oil at the next service interval, the MOS2 stays behind. It is now part of the metal. The next oil fill sits on top of the surface that is already protected. The oil film has something to work with. Boundary lubrication failure becomes rarer. Then rarer still. Then, in engines that have been treated consistently over years, it becomes effectively non-existent. This is not a theory. Japanese taxi operators documented this across their fleet starting in the mid-1970s. Engines treated with MOS2 from early mileage were consistently reaching 300,000, 400,000, 500,000 miles, with original internal components. Untreated engines from the same production runs, running the same routes, maintained on the same oil change schedules, were being rebuilt or replaced at 150,000 to 200,000 miles. The only variable was the $2 powder. You want to know why your mechanic has never mentioned this? You want to know why the dealership service advisor, who spends 20 minutes upselling you on a cabin air filter, has never once said the words molybdenum disulfide? Think about what a 500,000-mile engine means for the people charging you to fix engines. Your average American driver replaces their vehicle every 12 years or 150,000 miles, whichever comes first. The automotive service industry, not car sales, just service and repair, generates over $400 billion annually in the United States alone. Engine-related repairs are among the highest margin services in that ecosystem. Timing chains, piston rings, valve seals, rebuild heads, complete engine replacements. These are not 80 jobs. These are $3,000 to $12,000 jobs, and they happen because engines wear out. An engine that does not wear out is not a customer. MOS2 has never been hidden. You can search it right now. You can order it in bulk from industrial suppliers for less than the price of a cup of coffee per treatment. It is used in aerospace applications, military hardware, high-performance racing. NASA has used it, Formula One teams have used it. The information is public, but nobody selling you an oil change has any incentive to tell you about the powder that makes oil changes less critical. An engine rebuild's almost irrelevant. Here is exactly what you do. You purchase molybdenum disulfide powder. Technical grade, minimum purity, 98.5%. Not an MOS2 blend. Not an additive that contains some percentage of MOS2 alongside other compounds. Pure MOS2 powder, 100-gram container, costs between $8 and $15 and will treat your engine multiple times. For a standard 4-cylinder engine with a 4 to 5 liter oil capacity, you use 3 grams per treatment. That is approximately half a teaspoon. You mix it with a small amount of clean engine oil in a separate container first. This ensures the powder disperses evenly rather than clumping. You add the mixture to your engine through the oil fill cap with the engine cold or at operating temperature, both work. You then run the engine at idle for 15 minutes. This circulates the MOS2 through the entire lubrication system and initiates the bonding process on engine surfaces. You do this at every other oil change for the first 2 cycles. Then once per year as maintenance. That is it. That is the complete application. The first treatment begins surface integration within the first 50 miles of normal driving. By 500 miles, engine-experienced drivers often report a measurable difference in how the engine sounds at idle. Smoother, quieter, less mechanical noise. That is not placebo. That is boundary layer friction being reduced in real time. The engines that reach 500,000 miles are not miracles. They are not exceptions built in special factories with better materials. They are ordinary engines maintained by people who understood one thing that the industry hopes you never figure out. Wear is optional. The metal-on-metal contact that slowly destroys every engine ever built is not inevitable. It is a chemistry problem with a chemistry solution that has been available, affordable, and documented for 60 years. The Tokyo cab driver understood this. The fleet mechanics in Osaka understood this. The engineers who wrote the internal reports that eventually confirmed what those mechanics already knew understood this. You understand it now. The question is whether you do anything with it. The powder costs $2 per treatment. The application takes 11 minutes. The result, applied consistently from early mileage, is documented engine longevity that the service industry will never advertise and your dealership will never recommend. One small jar. One afternoon. The engine you're driving right now could be the last one you ever need to buy.